Hello everyone, welcome to the video tutorial of the MOOC course in Programming in Python. So today the topic of my presentation is algorithm. So let's have a look what is an algorithm. So algorithm is everywhere. It is not necessary that only in computer science we are using algorithm. Unknowingly we use algorithm to solve any kind of a problem in our day-to-day life. So let's take an example which is very common. So how to bake a cake? Whenever we are going to bake a cake, so we will follow certain steps, okay? So what we will do in the step number 1, we will gather some ingredients. The ingredients may be, suppose the flour, then it can be an eggs, then oil, then sugar, etc., okay? So in the next step what we will do, we will add those ingredients to the bowl, and we are not only going to add them, but we are going to add them in some certain proportion, like we are going to add 3 eggs, 1 cup of flour, 1 cup of oil and 1 cup of sugar. Then in step number 3, as you can see in the slide, we are going to mix together all those ingredients to make a batter, okay? In the next step, we are going to bake it in the oven in a predefined temperature. So after some finite amount of time, we will get our cake ready, we will decorate it and we can eat it, okay? So what we are doing in this particular case, we are following some certain steps to accomplish a task. So what is our task? Our task is to bake the cake, or we have to accomplish that particular task, okay? So I can give you another example. For example, if you are going to a bank ATM to withdraw some money, what you are doing? You are there also you are following certain steps. You have inserted your ATM card in the ATM machine, then you have give your secret PIN code, then you have done the ATM machine will ask you about type of transaction that you are going to make, whether it is from the savings account or it is from the current account. Then you are going to give the amount of money that you want to withdraw. Then after that, the amount will be withdrawn to you. So we are following certain steps to accomplish some tasks in our day-to-day life. Not only like this, whenever we are preparing any dish or we want to go to a particular destination, for example, to the railway station to make a phone call. So in this real life examples, we are following some steps. So those steps can be called as an algorithm. So what is an algorithm informally if we say? So these are nothing but some finite set of steps to accomplish a task, okay? So why we call this as a finite? The finite word tells you that the number of steps that you are following in that particular task should be countable, or number should be finite, okay? So if we look at the proper definition or the formal definition of an algorithm, it states that it is a set of step-by-step problem solving process in which a solution is arrived in a finite amount of time. So apart from using the word called set, it is much convenient to use the word called sequence. Why? Because in set the things can be repeated, but in algorithm the things cannot be repeated. So to look at the proper definition, so the second definition will be more appropriate to define an algorithm. So algorithm is defined here as a finite sequence of unambiguous steps or instructions which, if followed, would ultimately terminate and gives the solution of the problem. So as you can relate this particular definition with the first example that I gave you. So finite sequence of unambiguous steps or instruction means to bake the cake we need 4 or 5 different steps, okay? These steps are finite because 5 is a countable number, okay, which if followed would ultimately terminate. So the amount of time that it will take to bake the cake will ultimately terminate, and finally it will give you the solution of the problem, that is the cake you will get. This is nothing but algorithm we are following in every day in our life. So one thing you have to remember that not all the written instruction or not all the set of instruction can be termed as an algorithm. To be an algorithm, the set of instruction or the set of rules should follow some characteristics or some properties. So, let us have a look what are those characteristics or properties that an algorithm should possess. So, the first property tells you that the algorithm should have an input. Okay? So, what the algorithm will take as an input should be well defined. You have to remember that in an algorithm you can have a input or you may not have an input. Okay? So, in our example, while baking a cake, the ingredients can be termed as an input, but as a computer science student, if you remember the first program, that is the hello world program, if you have written, so it does not take any input. Okay? So, it simply print the word hello world or whatever within the printf statement it will print. So, in case of an algorithm, the first property tells you that the algorithm may have an input or it may not have an input, but if the algorithm is having an input, then it should be well defined. The next property of the algorithm is output. So, what is the algorithm will produce as an output? In case of an algorithm cannot be defined without any output. So, in case of an algorithm, you should have at least one output. For example, if you take an example of the bank ATM, the amount of money that you have withdrawn can be your output, or the mini statement can be also your output. So, in those cases you are having more than one output. Okay? So, in algorithm it should have at least one output, or if the algorithm does not have any output, so what is the purpose that we are using the algorithm? So, we have using the algorithm to have a output. So, every algorithm should definitely have at least one output. The third property of the algorithm is that it should be unambiguous. Unambiguous means every instruction or every rule that you are in the algorithm should have a precise meaning, or its meaning should be unique, or it should not have any ambiguity in it. Okay? So, if we have taken the example of baking the cake, if you remember the steps, so in the step number 2, I have written there add the ingredients. So, add the ingredients means it is having an ambiguity. How it is having an ambiguity meaning there? Because we have not specified here that you have to add the ingredients in the proper proportion. Okay? So, every instruction that you are incorporated in your algorithm should have a very clear meaning. It does not have any ambiguity. If you have taken this particular example, suppose in an algorithm if I write read, so what we have read? This particular statement in your program have an ambiguous meaning. So, if I specify here read a comma b, then it will have a very clear meaning that we have to read the value of the variable a and b. So, every instruction or rule that you are going to use in your algorithm should have a very precise meaning. The next property of the algorithm is that correctness. So, for what purpose you have written the algorithm, it should have the correct output. Okay? For example, if you are following that particular steps to bake the cake and you are getting a output that is not a cake, so it will not be a algorithm. So, you have to define the instruction in a very well formed and in a very well mannered that it will produce the correct output. The next property of the algorithm is finite. So, finite has two aspects. One is your algorithm should have a finite number of steps to accomplish, and the other thing is this: every instruction in your algorithm should take finite amount of time to execute. So, while one means it will be always true, so whatever instruction that you have written within this curly braces will be always true. So, it will be in an infinite loop. So, you have to forcefully terminate this program unless it won't be stopped. So, the second property is not defined, not fully satisfied here, that every instruction should be executed within a finite amount of time. So, finiteness in case of an algorithm means that every instruction should be executed within a finite amount of time, and the number of steps that are in an algorithm should be finite in number. The next property which defines an algorithm is effectiveness. Okay? So, whatever instruction or whatever rules is there in your algorithm should be effective. Suppose we have taken 5 different steps to bake a cake. So, all those steps if followed properly, ultimately we are going to have a cake. So, all those instructions are effective. So, we are getting the correct output, and in case of your algorithm, there should not be any unnecessary step in your algorithm. For example, we are going to check here to add 2 numbers. So, we have written this algorithm. Okay. So, as you can see in the third line, there is a statement called read C, that means read the value of the variable C, but this particular variable C does not have any effect on the output of the sum of these 2 numbers A and B. So, we have to remove this line, the third line, to make it more effective. So, these are the properties of the algorithm, so which will makes an algorithm. So, not all written instructions are algorithm. So, to make it as an algorithm, we have to specify all these properties. Okay. So, now see why we need algorithm. Suppose there is a need of a bridge over a river. Okay. So, what we will do first? We will ask a architect to design that particular drawing of that bridge, okay? And until the drawing is finalized, then only the construction of the bridge can be started. Okay? So, for example, if you have not make any design and you have started automatically the construction of the bridge, and if there is some kind of fall and you do not want to, you will not break the bridge and you will start it again. Okay? It will be wastage of money, it will be wastage of time, etc. So, the meaning is that the drawing of that particular bridge is your algorithm, that is the blueprint, okay? And the construction of the bridge is your program. So, there is a relation between an algorithm and a program. Okay? So, we can say that to better design an program, we should have an algorithm. Okay? So, if you know software development life cycle also, so you should know that the design phase always comes before the implementation phase. Okay? So, if you are going to develop any software, so first you have to do the algorithm. Until your algorithm is done, then you can you can start your coding. It is not that you will start your coding first, and if there is any changes, you will do a new program. So, to better design a program, we should have an algorithm. Okay? So, there is a slight difference between an algorithm and a program. So, I will just show you that what are the differences between algorithm and programs, but two things are very related to each other. So, to better design a program, we need an algorithm. So, see, in case of algorithm, we can write algorithm by using any natural language or English like language. Okay? But to write a program, we can take any language, programming language. Okay? Suppose C, C++, Java or Python, and you have to remember that to write a program in any programming language, your program should follow all the syntax rules that is within that particular language. But whenever you write any algorithm, you can be write using any simple like English, but it should be understandable. If you take the example of the baking a cake that was given in the first slide, so the 5 steps will be your algorithm. So, those the 5 steps, suppose collect the ingredients, add them to the bowl, mix together, then heat it in the oven, then decorate. Those were the algorithmic steps. So, so your algorithm is 1. So, but you can bake your cake in an oven, you can bake your cake in an OTG, you can bake your cake in a microwave, or you can even bake your cake in a pressure cooker. So, like this also, your program can be written in any language. Okay? So, it does not matter, but your algorithm is same for every program that you have written in different kind of language. So, the next question is, who will write an algorithm? Suppose there is a new recipe of recipe. So, that particular recipe will be written by a cook who know or who has the domain knowledge about that particular recipe. So, the algorithm will be written by the domain expert and the program will be written by the programmer. Next, you can see we can write algorithm in any paper or in any notepad or any word software, microprocessor word software. So, it is software and hardware independent kind of a thing, but to write a program you need that ID, you need that particular environment. So, algorithm is software and hardware independent, where you can say program is software and hardware dependent. The next property tells you that the difference between the algorithm and the programs, that we can analyze algorithms. Suppose again we take the example of that particular bridge. So, for that particular bridge, suppose 10 different architects will make their design. So, now we can analyze those 10 designs and we can select out of those 10 designs which will be the best, and we can select that particular design to be our algorithm. Okay? But we cannot analyze the program. So, what we can do with the program? So, we can test the program. See, we can test the program. How? Suppose that bridge, suppose after successfully constructed the bridge, we can test the bridge whether it is earthquake proof or not, whether it can take 100 tons of weight or not. Okay? So, these are the slight difference between algorithm and programs. So, hope you will be able to understand with these particular definitions or the particular examples. So, next we will see what are the different ways to represent algorithm. Okay? There are two standard ways to represent algorithm. One is known as the pseudocode and another is known as the flowchart. So, pseudocode is nothing but textual representation of your algorithm, and flowchart is the graphical representation of the algorithm, which will be discussed in this particular video tutorial by my colleague. So, next we will take an example to see how to find out the area of a rectangle. So, we know that to find out the area of a rectangle, so we have to know the value of the input variable, that is the length of the rectangle, yes, and width of the rectangle. So, after knowing this value, we know that how to calculate the area of the rectangle. So, how we can calculate? Yes, we can calculate the area of a rectangle by multiplying the value of the length of the rectangle with the width of the rectangle. Okay? And next we will get the area of the rectangle as the output. I am showing you two ways to write down the algorithm. Okay? Every algorithm that we have written will be always start with that keyword called start, and it will end with the keyword called end. So, you can either write read length, okay, or you can either write input length, it will be also correct. So, I told you that there is no strict instruction or there is no strict rules to write an algorithm, but there is a standard format that you have to follow. Okay. So, you can write read length, that is also correct, you can write input length, or you can even write enter length. Okay. The basic thing is that algorithm should be understandable. So, you can write read, input or enter. Then after reading the value of the length, then we have to take read the value of the width. So, you can either write read width, input width or enter the value of the width. Then we will calculate the area of the rectangle with the help of this particular formula. Okay. Then after calculating the area of the rectangle, we will display the value of the area of the rectangle either using display keyword or you can write the output keyword. Then we will end our algorithm. Okay. So, next we will see how to write an algorithm. So, to write an algorithm, we need some prerequisites should be known to us. So, the first thing is this, the problem that is to be solved with that help of that particular algorithm. Okay. The next thing, what are the constraints of the problem that are going to be defined whenever we are going to write the algorithm. The input to be taken by the algorithm next will be a prerequisite to write the algorithm. Then the output that is to be expected from that algorithm will be the next prerequisite, and next is the solution to this problem, which will be written with those constraints that are defined in the algorithm. So, let us take an example. So, these are the different 5 steps or 5 prerequisites that you should know before writing an algorithm. Let us take an example to add 3 numbers. Okay. Suppose you are going to define the first step, the problem that is to be solved. So, what is our problem? We have to add the 3 numbers and print their sum, that is our problem. So, next can you tell me the constraint of the problem? What will be the constraint? constraint whenever we are going to add these 3 numbers. Yes. the numbers that we are going to be add only contain digit and not any other character. So, that is our constraint. There may be another constraint also, but I am taking this constraint as an example. Okay. Prerequisite is the input. So, what will be the input? If there are 3 numbers, then there will be 3 inputs. Okay. What is our output? Output will be the sum of these 3 numbers taken as the output. Okay. So, how to find out the solution of the problem? So, the solution of the problem can be found by adding these 3 numbers. Okay. So, addition can be done with the help of this addition operator also or bitwise operator also. So, in the next slide I will show you how to write the algorithm for adding 3 numbers using the addition operation. So, in this example, so we will be showing how to add 3 numbers with the help of the addition operator. So, as I told you in the last slide that every algorithm should be start with the keyword called start. Then we have to get the input from the 3 numbers. So, we have to read the value of the variable number 1, num2, num3. So, I have specified the name of the variable as num1, num2, num3. Somebody can write input ABC or what, or somebody can write read the value of the variable num1, num2, num3. There is no restriction, simply it should be, we should be able to understand the different instructions that are in the algorithm. So, after reading the value of the variable, 3 different variable, we are going to calculate the sum. Okay. The sum is very simple. So, whenever we are going to find out the sum of this variable, we are simply going to add the numbers number 1 plus number 2 plus number 3. Then we get the value of these variables as a sum in the variable called sum. Then we will display the value of the sum, and then we will going to print that particular value of the variable print, and our algorithm will be ended here. So, this is one way to write the algorithm. Let us take another example. So, in this example we have taken the example to find out the largest of 3 numbers in an algorithmic procedure. So, if you think what is the step number 1 is to start the algorithm. So, since largest of 3 numbers, here also we have to read the value of the variable ABC in step number 2. So, since we are going to compare it, we have to use the operator if else. Okay. In the else part, if A is less than B and B is greater than C, then B will be the largest number. And in this particular else part, where A is less than B and B is also less than C, then we will print C as the largest number. Then after this, we will stop our algorithm. So, there is another way, this is one way to write this algorithm. So, there is another way to write an algorithm by using the go to statements. Okay. So, the same example I have taken to find out the largest of 3 numbers. So, the first step will be to start with this start keyword, then we will read these 3 numbers as num1, num2 and num3. Then in the step number 3 I have written if the first number is greater than the second number, then we will go to step number 5. Okay. And if the second number is greater than the third number, then we will print that number 2 is the largest, else this number 3 will be the largest, and else if this particular condition is not satisfied, then it will go to the step number 6. Okay. So, in step number 5, which is referred from here, I have written here number 1 is greater than number 3. So, that then I can print number 1 is the largest, or else I can print number 3 as the largest. So, this is one way, another way of writing algorithm. So, one thing that you have to remember this, not all written instructions are algorithm. To make all written instruction as algorithm, the algorithms should possess all those 5 different properties, and you can write the algorithm in an understandable format. It will always start with the keyword called start and it will always end with end, and within that you can write your algorithm in an understandable format. There is no strict restriction of the anything in writing an algorithm, but there is a format that you have to follow. Hope you will be able to understand how to write an algorithm with these 2 examples. Hope to see you in the next video lecture. Thank you very much.